One question on the CUNY assessment test usually involves a relationship between fractions, decimals, and percent. And it's important to be able to switch from one form of a number to another. Let's start by changing fractions to decimals. Okay, let's say we have a fraction 3/8. In an earlier tape, I reminded you that this means 3 divided by 8. Okay, 3 divided by 8. You put the decimal point in the answer over the decimal point here. And we begin our division. 8 into 3, no. 8 into 30 goes 3 times. 3 times 8, 24. We subtract 10, take away 4, 6. Bring down the next decimal, next digit. 8 into 60 goes 7. 7 times 8, 56. Subtract 4, bring down the next digit, 0. 8 goes into 45 times. And in this case, we have remainder 0. And we can write 3/8 as 0.375. That's its decimal representation. Now, in this particular case, the decimal representation terminated. That is, after this point, all the rest of the digits would be 0, and they could be omitted. Sometimes the decimal representation does not terminate, in which case they might ask you to give the answer correct to the nearest tenth, or the nearest hundredth, or the nearest thousandth. In this particular problem, they might have said, give the answer correct to the nearest tenth. What you do is you would look, you want it correct to the nearest tenth, you look at the hundredths place. If the number in the hundredths place is 5 or more, you would add 1 to the digit in the tenths place, and you would write this correct to the nearest tenths as 0.4, 4/10. If it had been 0.315, correct to the nearest tenth, it would be 0.3. If the number in the second place is less than 5, then you leave it alone, the 3. If it's more than 5, you would round up to 0.4. So if it's correct to the nearest tenth, you would give this answer as 0.4, because the number in the hundredths place is 5 or more. Here, correct to the nearest tenth, you would write 0.3, because the number in the hundredths place is less than 5. If they had said correct to the nearest hundredth, you would look in the thousandths place. If the number was 5 or more, you would round the number in the hundredths place up. So 0.375, correct to the nearest hundredth, would be 0.38. Similarly, here, correct to the nearest hundredth, you would look in the third decimal digit. The thousandths place, you'd see a 5, and you would round up to 0.32. So correct to the nearest hundredth, this would be 0.38, and the number 0.315 would round to 0.32. Okay, as I said, in this particular problem, it did terminate, but very often the decimal representation does not terminate, and in those cases, they expect you to round, and they'll tell you, to which decimal digit to round. Okay, let's try this example. Change 5/7 to a decimal, rounded to the nearest thousandths. Okay, 5/7 means 5 divided by 7. 5 divided by 7. Now I want it correct to the nearest thousandth. I want it correct to 3 decimal digits, which means I must carry my work to 4 decimal digits and then round back to 3. Okay, how many 7s in 5? No, 7s into 50 goes 7 times. 7 times 7, 49. Subtract 1, bring down the next digit, 0. How many 7s in 10 goes 1 time? 1 times 7, 7. Subtract 3, bring down the next digit, 0. How many 7s in 30 goes 4 times? 4 times 7 is 28. Subtract 2. Bring down the last digit that we need for this problem, because we want it accurate to 3 digits, 3 decimal digits, so we're just going to carry it to 4 decimal digits. How many 7s in 20? 2 times 7 is 14. There is a remainder, but we're going to stop right now. We want it accurate to the nearest thousands, accurate to 3 decimal digits. We look at the 4th decimal digit. Since it is less than 5, we will leave this alone as 0.714, 714 thousandths. To find it accurate to the nearest thousandth, that means that's the 3rd decimal digit, we have to carry it to 4. Okay, if this number is 5 or more, we would have raised this to a 5. Since it's less than 5, we leave it alone as a 4. Okay, let's try the next example. Change 4/13 to a decimal, rounded to the nearest hundredth. Four thirteenths means 4 divided by 13. 13 into 4. Now, I want it to the nearest hundredth. I want it accurate to 2 decimal digits. Therefore, I will carry it to 3 decimal digits and round correct to 2 decimal digits. How many times does 13 go into 40? 13 times 3 is 39. We subtract 1. Bring down the next digit, 0. How many times does 13 go into 10? 0 times. Bring down the next decimal digit. How many times does 13 go into 100? It goes into 100 7 times. 13 times 7, 91. Okay, we can subtract and continue, but this is all we need. We have 3 places. We want to round accurately to 2 places. Okay, so we're going to give as our answer 0.31. Since the 3rd decimal digit was over 5, we raise the 2nd decimal digit by 1. So instead of 0.307, we round it correct to the nearest hundredth, 0.31. And I don't know, but you might have, for example, other possibilities on the assessment test. They might give you, for example, even 0.307 as a possible answer. But they want to the nearest hundredth, which means you're supposed to give it to 2 decimal digits. All right, we now know how to go from fractions to decimals. Sometimes you're expected to be able to go from decimals to fractions, back again. The decimal representation that they will give you will be a terminating decimal, and they will expect you to write it as a fraction. Okay, it is not a difficult thing. All you simply have to do when you have a terminating decimal, you're going to rewrite this as a fraction. The numerator of the fraction will be, if you ignore the decimal point, okay, you see the number 3. That will be the numerator, divided by an appropriate power of 10. That is, by 1 followed by the right number of zeros. The right number of zeros would be same number of zeros as there are decimal digits in the original problem. There are 3 decimal digits, so you will follow the 1 by 3 zeros. So the proper power of 10 would be 10 to the 3rd power, or 1,000. This is 3 thousandths, 3 divided by 1,000. If we have 0.3, this would be 3 divided by the appropriate power of 10, which would be just 1 followed by 1 zero, since there's only 1 decimal digit. And of course, 0.3 is the same as 3/10. 0.03, 3 divided by the proper power of 10, which would be 1, followed by 2 zeros, since there are 2 decimal digits, 3/100. 0.034, we would write this as once again, ignore the decimal. The number is 34 divided by 1, followed by 1, 2, 3 zeros, 1 for each of the decimal digits, 34 thousandths. 0.12 would be 12 over 100, 12 hundredths, because there are 2 decimal digits. And finally, 0.0005 would be 5 divided by 1, followed by 1, 2, 3, 4 zeros, 5 ten-thousandths. So we have basically gone over the relationship between fractions and decimals. Now, how do percents figure into the work? Changing percents to fractions. Basically, percent means hundredths. And all you have to do, if you have 37% and you want to change it to a fraction, you think of it as 37 hundredths, or 37 divided by 100. So you remove the percent sign, you divide the resulting number by 100. And then if you want, you can reduce the corresponding fraction to lowest terms. For example, 25% is equivalent to 25 hundredths, which if you wanted to, you could divide numerator and denominator by 25, reduces to 1/4. 25% is equivalent to 1/4, the fraction 1/4. 15%, 15 hundredths. And if you want, you could leave it either 15 hundredths, or if you're looking for a multiple choice answer, they might have reduced to lowest terms. You could divide numerator and denominator by 5 to get 3. 15 divided by 5 is 3. 100 divided by 5 is 20. 3/20ths. Okay, that's if you want to go from percent to fractions. Sometimes you want to go from percent to decimals. Okay, well, if you already have it as a fraction, for example, 37 hundredths, you could, of course, write that as 0.37. If you intend to go to decimals, it's better not to reduce it to lowest terms. It is better to leave it in terms of division by 100, because division by 100 can be accomplished by moving a decimal point. Whereas we're dividing by 100, basically that means move the decimal, which, since you didn't see it otherwise, we assume it's after the 7, move the decimal 2 places to the left. Okay, similarly over here, 25 over 100, the decimal point is here, move it 2 places to the left. To divide by 100, you move the decimal 2 places to the left. We've seen earlier in another tape, to multiply by 100, you move the decimal 2 places to the right. Okay, 25 times 100 would be 2500. Okay, 25 divided by 100 would be 0.25. 15 divided by 100 would be 0.15. Let's try some more of these. Okay, if I said 12% and I wanted to change percent to decimals, okay, it's a good idea to stop by and to change it into a fraction, then change it into the decimal. 12% means 12 hundredths, which is 0.12. There are going to be practical reasons for doing this. For example, when you figure out sales tax, you buy something, if it's 8% sales tax, you would have to be dealing with a fraction of 8 divided by 100, or, now moving the decimal 2 places to the left, be careful here, back 1, back 2, it's going to be 0.08. 8 hundredths, 0.08. 12 hundredths, 0.12. Okay? Sometimes somebody might get a very big raise. okay? You might be dealing with numbers like 150%, okay? Don't let that floor you. It's still 150 divided by 100. Move the decimal point 2 places to the left, and this is equivalent to 1.5. Or 1.50, but you can ignore that. In other words, you're moving it 2 places to the left, 1.50, but that, of course, is equivalent to 1.5. Okay, now, usually the work with percent comes into play because there are word problems involving percents, and you have to show that you know how to deal with the corresponding decimal. Let's look at some examples. These are examples involving percent problems. It may be something very direct, like, what is 30% of 80? It may be a much more involved problem. The word of in this problem is your key to multiply. It's your tip-off for multiplication. I am interested in 30% of 80. That means I take 30% written as a decimal, okay, or as a fraction. 30% is 30 100ths, or 0.30, and I multiply it by 80. It could be done either 30 100ths, 30 100ths of 80, or in this form here. Now, if you do it as a fraction, you can multiply the numerators. You get 2400 over 100. Okay, you could divide numerator and denominator by 100 to get 24. If you do it as a decimal, you would take 30 times 80 and get 2400. And then you would say there are 2 decimal digits in this factor, none in this. So the final answer should have 2 decimal digits. So the answer would be 24. So one way or another, whether you want to change the percent to a decimal or to a fraction, you can handle this problem. What is 30% of 80? You calculate 30% of 80 by multiplying 0.30 times 80. Okay? It might appear in terms of a problem like the following. A family's bill in a restaurant is $75. They want to leave a 15% tip. How much money should they leave for the tip? Okay, don't let the words throw you. What we're asking for here is the same as really the last question. We're asking, what is 15% of $75? Just like the last problem says, what is 30% of 80? What is 30% of 80? And we multiplied 0.30 times 80. Here, when the smoke clears, we're just asking for what is 15% of 75. The bill was $75. 15% of that is going to be left as a tip. So we want to take 15% of 80, that is to multiply 15/100ths, 15% of 75, to multiply 15/100ths, or 0.15, times 75, and that'll be how much we should leave for the tip. So we have to go over here and calculate 75 times 15. 5 times 5, 25. Carry the 2. 5 times 7, 35, plus 2, 37. Then 1 times 75, but indent 1. And we get 5. 5 and 7, 12. 4 and 7, 11. Okay, now we had no decimal digits here, 2 decimal digits there, so there should be 2 decimal digits in the answer. So the tip should be $11.25. Okay, now the percent problem may be stated slightly differently. Okay, they may say 40 is 20% of a certain number. Find the number. Forty is 20% of a certain number. Find the number. Okay, what they're really saying here is 40 is 20% of what number? Okay, basically we turn these into equations. Over here, we said, what is 15% of 75? The box represented what? Okay, that was what we were looking for. What is was equals 15% of 75 meant 15%, 0.15 times 75. What is or equals 15% of 75? In this problem, we have it slightly different. They say 40 is, that's the equal, 20% of what? 0.20, 20% written as a decimal, of what number? Okay. 20% of what number, this is an unknown, something that we have to calculate, is going to be 40. Okay, well, if I said to you 12 was 3 times what number, you would all say, well, the number here is 4. And how did you figure out what that was? You basically divided 12 by 3 and you got 4. Now that one you can do in your head. Okay? If I say 12 is 3 times what, you know the answer is 4 because you divided 12 by 3. Okay? Similarly, you can figure out the number here by saying divide 40 by 0.20. And that should be the number. That's what we're looking for. Now, to do 40 divided by 0.20, to finish this up, we learned when we want to divide by we have to make sure the number in the denominator is an integer. To accomplish that, we will have to use the fundamental principle of fractions, that is to multiply numerator and denominator by, in this case, 100, so that the denominator becomes 20. You multiply the denominator by 100 and the numerator by 100. When you multiply by 100, you move the decimal 2 places to the right. So 40 will become 40 followed by 2 zeros, or 4,000. 0.20 will become 20. 4,000 divided by 20. We can first divide numerator and denominator by 10, and then divide 400 by 2 and get 200. So the answer to the problem is 200. 20% of 200 would turn out to be 40. 20%, by the way, could also be thought of as 0.20, 20/100ths, which reduces to 1/5. So what we're really asking is 1/5 of what number is 40, and 1/5 of 200 is 40. Okay, so far we've seen the what appearing as in two different ways. What is 15% of 75? Where you do the multiplication and the answer is what you're looking for. Here, 40 is 20% of what number? And you have to do a division. Another possibility is the following. What percent of 80 is 16? This can be rewritten as 16 is what percent of 80? 16 is or equals what percent of 80? Okay, what do you have to multiply by 80 to get the 16? And the answer, of course, would be 16 over 80. In other words, you would divide 16 by 80 to figure out what the unknown is here. What has to be, just like when I had, remember, 12 is 3 times what? You figure out the what by dividing 12 by 3. Here you figure out the what by dividing 16 by 80. Okay, to divide 16 by 80, you can actually do it by long division if you want. You could reduce this to lowest terms and do it that way, or do it by long division. Okay, putting the decimal point after the 16 and then in the answer in the same place. How many 80s in 160? It goes 2 times. 2 times 80 is 160. And then, of course, you get that. So this is equivalent to 0.20 or 20%. So what percent of 80 is 16? Okay, 20%, which is equivalent to 1/5. In other words, 16 is 1/5 of 80, or 20% of 80. Now, there are practical reasons that you might want to be able to do a problem like this. Most of you have done calculations like this in one time or another because you've gotten a test and you've been told you had a certain amount correct and you want to figure out what percent correct you got on that test, grade on the exam. For example, there are 25 problems on a test. A student answers 17 correctly. What percent of his answers are correct? Or they might have said, what score did he receive on the test? The score corresponds to the percent of his answers that are correct. Okay, he got 17 out of the 25 correct. In other words, 17 is what percent of 25? 17 is or equals what percent, what number times 25? Okay. The answer would be 17 over 25 written as a percent. In other words, he has 17 out of the 25 correct, so he's gotten 17/25 correct. We want to now change this to a percent. Percent means hundredths, so if we can either write it as a decimal and change it that way, or in this case, it's simple to multiply numerator and denominator by 4 and get an equivalent fraction, namely 68 over 100, which can then be turned very simply into 68% for the final answer. So if he gets 17 out of 25 correct, his score in the exam would be 68%. If you didn't see to do it this way, it's perfectly okay to say 17 divided by 25 means 25 into 17, put the decimal point there. How many 25s in 170? 6 25s would be 150. Subtract, get the 20, bring down the next digit. How many 25s in 208? And it goes evenly. So 0.68, which of course would then be written as 68 hundredths or 68%. And certainly if there had been 33 questions on the exam, some number which was not a factor of 100, then you would want to do it in that manner. You would change it into the decimal and then write it as the percent. Another possible example would be something like this. A worker earns $150 each week. If 18% of his salary is withheld in taxes, how much money does he actually bring home? We will assume he brings home all the rest. He doesn't stop on the way, spend it on anything else. Aside from what they take off in taxes, he brings home all the rest of the money. Okay, first thing we'd like to do is to figure out his taxes. The taxes are 18% of his salary. 18% or 0.18 times his salary of $150. So we'll have to multiply 150 times 18. 8 times 0, 0. 8 times 5, 40. Carry the 4, 4 and 8, 12. Go in 1, and then 1 times 150, giving us 0.072. Now, we had 2 decimal digits here, no decimal digit there, so 2 in the answer. So the taxes amount to $27. And chances are one of the choices on the assessment test would be $27, but that's not the answer to the question. How much money does he actually bring home? Okay. His take-home pay will be his salary minus his taxes. So the correct answer will be the $150 that he earned less the $27 that he paid in taxes, so he will be bringing home $123. 150 take away 27. Okay, 10 take away 7. 3, 4 take away 2, 1. $123 is what he'll take home. So don't fall into a trap by checking an answer of $27. That's his taxes. Okay, but takes home his salary, take away his taxes. $123. For the last problem on this videotape, let's try this. 35% of the people at a union meeting voted in favor of a proposal. If 210 people voted for the proposal, how many people were at the meeting? "35% of the people at a meeting voted in favor of the proposal. If 210 people voted for the proposal, how many people were at the meeting?" Okay? If you can sift through the words here, what they're really asking is 210 is 35% of what? 210 people voted for the proposal. That was 35% of the people present. Okay? 35% times what number would give us 210? 35% of the people voted. We don't know how many there were, but 35% of them came out to be 210. So 210 is 35%, or 0.35 times what number? And the number would be 210 divided by 0.35. Okay, to do 210 divided by 0.35, once again, to divide here, the denominator has to be an integer. We will multiply numerator and denominator by 100 in order to make the denominator a whole number. Moving the decimal 2 places to the right, the denominator becomes 35. The numerator becomes 210, followed by 2 zeros, or 210,000. And then we have 21,000. 21,000 divided by 35. 21,000 divided by 35. Okay, how many 35s in 21? It doesn't go into 210. It goes 6 times. 35 times 6. 5 times 6 is 30. Carry the 3. 3 times 6, 18, and 3, 21. And then bring down the next digits. We need, the answer is going to have a decimal point here. So we have to put the other zeros in there, and the final answer is 600. 600 people were at the meeting. 35% of 600, if you take 0.35 and multiply it by 600, you will get 210. That's the amount of people who voted in favor of the proposal. And we had 21,000 divided by 35 after we multiplied numerator and denominator by 100. And that brings us to the end of this tape.